here now in a concrete passive house, and we want to look especially at thermal bridging. We've looked in previous series at the insulation levels required for passive house. We've also looked at air tightness, and this next concept we want to talk about is thermal bridging. And what is a thermal bridge? Let's have a chat about that for a second. If we imagine we got this floor area here and it's all really well insulated, but we have this wall, this concrete wall, which is penetrating the underfloor insulation. You have then a break in the insulation layer. The insulation layer is not continuous, but we have this concrete wall going down to the cold earth. And because we have a break in that insulation layer caused by this wall, there's potential for a thermal bridge there. So that's what a thermal bridge is. It's where you have discontinuous layers of insulation in a house. And in a passive house, we must eliminate those completely. So in this series, we'll look at a number of techniques and design details that you can use to eliminate them. We're on site here at what would be a typical construction project in northwestern Europe, where we're using a lot of concrete and masonry in the thermal envelope. And you have to imagine ordinary concrete is a great conductor of heat, so you have to be very careful wherever you're using such products, such that you don't create a thermal bridge. And here we are now at the foundation level, and you have to imagine the ground is cold in the winter time, and we have a cold ground, cold foundation, and these are our internal walls in the house, and we have to create a so-called thermal break between the walls in the house and the cold foundation. And there are excellent products on the market now which we can use for that. You have these blocks here, for example. They're low conductivity blocks. They're very light. They're actually made from aerated concrete, and they create a very effective thermal break between the internal concrete wall and the foundation wall here. Wherever you have a thermal bridge, you'll also have reduced surface temperatures. And reduced surface temperatures can create two impacts. First of all, it can create discomfort for the occupants. So you might sense a chill in a room or a draft, even though there's no draft, because you have this temperature stratification in the room. But the other more critical aspect is the potential for great conditions for mold growth. And those of you who live in old houses perhaps, and maybe you have evidence of mold in the bathroom, for example, that's typically the effect of a thermal bridge. So you've got low surface temperatures and poor ventilation, which is excellent for mold growth. So in building to the passive house standard, we're not only reducing our energy loss, we're actually increasing the thermal comfort, and we're also increasing the health of the building. So thermal bridges have those three impacts: energy loss, thermal comfort, and health. The Passive House Institute have defined quite precisely what constitutes thermal bridge free construction, and the units are watts per meter Kelvin. And if something has been designed, if a junction has been designed to be 0.01 watts per meter Kelvin, then it's regarded as thermal bridge free. And there's a number of ways you can achieve this thermal bridge free design. We have some products here to show you some examples. So this is an aerated concrete block. It's load bearing, but it's quite porous and therefore creates a good thermal break between, let's say, your foundation wall and the internal wall. This is another very interesting product where you might want a cantilevered concrete balcony. So let's imagine your house is on this side of this element and you want a concrete balcony on the other side. This creates a perfect thermal break between inside and outside. So that's another interesting product. Another product we can look at, this is also load bearing. You can see the two pieces of concrete there, but it's completely wrapped in insulation so that it's load bearing vertically, but it creates a perfect thermal break horizontally. And the last product we can look at in terms of thermal bridge free design is called foam glass, and this is also very lightweight and would be used in a similar context to this aerated concrete. So achieving thermal bridge free design is very important. The design and detailing is very critical, and central to that is the use of really good products like we've seen here. So we moved inside the house now, and we're really fortunate at this phase of the construction that we can see a classic build-up of the ground between the floor and the finished floor level in the passive house. So let's have a look at that now. First of all, we've got our ground here, and just above the ground we have a radon barrier which protects the house from any radon coming up into the inside. Now we step up onto the structural floor slab. So this is the structural layer that protects the floor of the house. The next thing we step up onto is this really impressive layer of insulation, and this really gets across the point that we have to insulate our houses really, really well, including in the floor. So you can imagine there's very, very little heat loss down through this insulation into the floor slab, so that's excellent. And the next point to point out is the positioning of the thermal break that we discussed earlier. And here we have our porous concrete block, and it's positioned exactly at the right level. What still has to go onto this is a 50mm or 2-inch floor screed, and you can see then that the floor screed which goes on top of this layer is connecting to a warm wall, not a cold wall. And this warm wall has been created by this thermal break. So we've seen the perfect build up here of the structure of the floor in a passive house. Now, in case you're wondering, why do we have more quinlite blocks here? Surely we could finish here at the floor screed level. That's a good point. And the reason for this is the room next door is a little bit higher. There are varying levels in this house. And so what we've done here is we've put in 2 extra courses of this porous concrete block to allow for the higher floor level next door. What you build your passive house out of is really up to yourself. You can use wood frame, you can use straw bales, or you can use concrete, such as like we've got here in this house this morning. The interesting thing about concrete is there are various types of concrete, and some types of concrete have a very low carbon content, so they're better for the environment. And this is something we need to think about when we're designing low energy buildings. It's not just about the energy loss and the comfort and cold bridging and everything we've discussed, but it's also about the so-called embodied energy in our buildings.
We are here at Ecoslem's Dublin plant, where we make our more environmentally friendly cement. The carbon footprint of GGBS cement is 20 times lower than the carbon footprint of ordinary cement. The use of GGBS cement saves embodied CO2. This is as opposed to operational CO2, which is saved when you install solar panels and insulation. For reasons of chemistry, GGBS cement is always blended with ordinary cement. There are various blends available. The typical blends are 50 to 70% in your foundations, 50% in your blocks, and 50 to 70% in your walls. It is also very useful in ICF systems. Concrete made with GGBS cement is stronger, more durable, and lighter in colour. The concrete will also be more fire resistant and reduce the risk of efflorescence, the white staining you see on concrete walls. On a typical house, the use of this material in the floors, foundations, walls and other elements will save over 10 tonnes of CO2, the same as leaving your car at home for over 3 years.
We've looked at the critical junction between wall and floor, but there's a lot of junctions that we need to consider when we're designing our passive houses. One of these junctions is the window junction, and if you imagine for the moment the amount of linear meters or linear feet there are for all the windows in the passive house, there's potentially great heat loss out through that thermal bridge as well. So that has to be well designed. Another critical junction that we have to consider is the wall to roof detail. We're not at that stage on this project yet, but that likewise has to be properly detailed. So you have to consider the passive house in its entirety, look at where all the junctions are, consider whether they're thermal bridge free or not, and if they're not thermal bridge free, you have to come up with a special detail and use special products to achieve that.